Attendance enabled, guys. Guys, attendance is enabled, so please put in. And we'll just wait for maybe 1 more minute. Is there a class currently going on? Is there any class currently going on?
No, sir.
Okay, so then people should come up. Okay, I don't think so. It's increasing. It's pretty much static. Okay, it's probably increasing now. Uh, okay, so anyhow, we'll start. So basically, this week the new timetable is applicable. So so there are some changes in lectures and lab schedule. I've heard that there is probably a clash. So please please have a talk with Dr. Anand. She actually knows the changes about the changes. It's just that probably she too will talk about it herself. If she forgets, you can just remind her. Okay? Anyhow, so this week's lab, we were supposed to have the first lab exam, but I realized that I have not really taught anything as of now in C++, and um, even if I had, maybe it would have been a difficult thing because we have a holiday on Wednesday. I think it would have been fine if we had followed the new timetable. I guess in that case, the Wednesday lab would have shifted to either Thursday or Tuesday, something like that. But yeah, anyhow, we are not going to have the lab exam this week. We will have it next week. Okay. So rest, I will actually send you guys a mail about the new dates of lab exams based on the days of the week, because the days of the week may have changed. So that I'll send you a separate email to inform you about the labs. But this week too, it will be a practice lab. And by the way, please keep in mind that when you do your code in this semester, um, as I've said, that basically try to think from the perspective of building a system. Okay, just matching the output. Don't do it like that, right? I mean, you're going to do that in data structures anyhow, right? So in data structures, you get a problem, you get a set of test cases, and the objective is to basically produce the same output. Okay, it doesn't matter whether you write 100 lines of code or 10,000 lines of code. The idea is to produce the same output. But here, in because the in the lab exams, your evaluation will be kind of subjective. Okay, when I mean kind of, is it means that just producing the same output is not enough. Okay, you have to learn the art of modeling as well. So in this subject, when you write code, um, don't just try to match the output, try to also figure out, like, this is what this particular problem is all about. Okay, it's about for example, the first practice problem I gave, it was hinting in that direction, that you are now given a project to build upon. Of course, you can't build a project in a 1 or 2 hour lab, but think from that perspective. Whatever code you write, okay, so for example, try to create some structures. Once we have done with classes, try to create some classes. Think about what will be what will be the aspects of those classes. What should those classes contain, and so on and so forth. So it's not just about producing the output, because of course, producing output is many a times uh, the only thing that we want. But please keep this in mind, that in this semester your evaluation will be more subjective in nature, that not just the output, the TAs will be asked to look at your code as well, like how have you solved the problem, not just whether you have solved the problem or not. Okay, so please keep these things in mind. Okay, so let's start then. I think we have 70 people now. Sorry, this is week 2, right? Yeah, we started with week 2, and this is lecture 1. I think I have made a mistake there as well. So let's start. Mm. So in the previous week, what all things did we look at? So first thing that we saw was that there are two approaches to building systems. One is kind of the structural approach. And by the way, go ahead. Someone has a doubt. Yeah. So again, the same thing, that if you have a doubt, please unmute and ask. Okay. So In the previous week, what all things we saw that there are two major ways in which systems could be built. One is the structural approach. The other one is the object-oriented approach. In the object-oriented approach, uh, we try to put data plus behavior within the same container. Okay. Whereas in the structured approach, the data and the behavior, or when I say behavior, I mean the operations over the data, they are decoupled with each other. They are not really dependent on each other. So this is where object orientedness kicked in. So from now onwards, for in every week there will be two types of lectures. First, we will have a look at some modeling techniques. This will go on in parallel, and at the same time we will also look at some C++. So basically from here onwards, there will be a bifurcation in the course. Okay. There will be some discussion on the modeling techniques, and there will be some discussion on the coding part. So and these are not necessarily in sync with each other. Okay. These are So there are basically going to be two parallel tracks on which we are going to walk upon. So you need to be good in both aspects, because in the exams you will be asked questions from both aspects, the modeling part as well as the coding in C++ part. So from here onwards, please be more attentive. So anyhow, so today's lecture is on the modeling part of the syllabus. Okay, so let us try to understand the concept of domain versus application model. So what does this mean? Essentially, what happens is whenever you are supposed to build a particular application, the first thing you need to know is you need to know that particular domain, the domain in which you are going to build an application. Let me give you the simplest of example. Some of you may have a family business, for example, right? I mean, uh, your family might be either producing something in some factories, or it might be involved in procuring something from somewhere and then transporting it or sending it somewhere else. They might be in the retail division, they might be in the wholesale division. Some of you, okay, maybe your families might actually be working somewhere like this in some part of the ecosystem. So let us also assume that you are planning to do something which helps your family runs your business. Okay, so you are planning to build some software solution, okay, for them. So what is the first thing you need to know about it? The first thing you need to know about is your business itself. I mean, you should probably sit with your parents or your elders of the family, and they will explain to you what the whole business is all about. Okay, it has nothing to do with IT, it has nothing to do with computer science. It is pure business terminology. You have to understand what are the terminology, what are the terms within your business domain, right? So they'll tell you these are our customers, these are our suppliers, this is probably the raw material, this is how much time it takes to produce the end product from the raw materials, this is our maintenance cost, so on and so forth. So all this is basically business information. It has nothing to do with computer science. This is all about the domain, the actual arena in which you are supposed to build the application. So this level of information, this kind of information, is captured through a process called domain modeling. Okay, and whatever is the output, we call it a domain model. So the idea of a domain model is to capture the domain. It is to capture the business aspect of that particular domain. I repeat, it has nothing to do with IT, it has nothing to do with computer science. A domain model is created by people who understand the domain. They need not be computer science people. Okay, they need not be IT guys. These are guys who worked in a particular domain. So for example, um, these companies like Infosys and TCS, right, they hire a lot of people from the IIMs. Okay, not from IITs, IIMs. It is possible that the IIM guy may have had a graduation from some IIT, but the person might actually be hired for being an IIM graduate, right? Why do they do that? Because they also need domain experts in their companies. Okay, so for example, they also hire people who, let us say, who worked for 10 or 15 years in banking, okay, who has done nothing in IT, but that person knows banking. Banking is on his or her fingertips all the time. So any banking question you have, you go and ask that person, and he or she will be able to tell you. So all these big IT firms, they hire certain people which are essentially domain experts. Okay, they have knowledge in one particular domain, and they are the people who help them with understanding that particular domain. If they get a project from that particular domain, there will be a lot of questions about how that domain operates. So the domain modeling part is about modeling a domain. In most cases, it is not your job as a computer science engineer. Domain modeling is not your job. You may be involved in the process, but it is usually done by people who understand the domain. And then comes the process of application modeling, or building a model for the particular application you are going to build for that domain. Okay, so let us say now, you want to do something for your family business. The first thing is you went to your elders and you understood how the business works, and now you say, okay, let us say, I want to automate the, let us say, currently all the shipping labels are, let us say, printed manually, something like that, right? So you say that, no, I will create an application that somehow prints all the shipping labels automatically. You just have to click one press, one button, and then it will fetch all the names of our retailers, and then it will, print it in a nice way, and all the invoices will be printed, so on and so forth. I'm giving a very simple example, but the idea is, you essentially say that this is the domain in which I am going to work in, and this is the application I'm going to build for this domain. Okay, so you are going to be responsible for this part of the problem, modeling the application based on the domain model. So you have to understand the domain model, but only up to that extent, so that you can model your application. So this is the difference between a domain model and an application model. Any questions here? Is this part clear? What is the difference between a domain model and an application model? You are not supposed to build the domain model. It is probably done by the people from IIMs, let us say. Okay, they are going to be the one who will tell you everything about the domain. But once they've told you, and then they'll tell you this is the application that is supposed to be built, you are supposed to now build a model for your application, your particular application, which may or may not use all the information that is there in the domain model. Is this part clear? Shall we move forward? Okay. So now when you're going to model your application, so from here onward, all that we are going to talk about is application modeling. It is not domain modeling. Okay, we are only going to discuss the application modeling. Domain modeling, as I said, is, let us say, let us assume that someone else has already done it for us. So we are only going to talk about application modeling. So there are different ways or different aspects of a system that you need to model before you start coding, right? So what are these aspects? So for example, the first thing you probably saw in the previous week's examples was that there was a relationship between these two classes, right? I mean, there was a class called letter, and there was a class called, I think, what, postal service or service request, something like this. And you realize that there is a relationship between them, that a letter is sent through post with the help of a postal service request. So there is a relationship between these two classes. Okay, so this is probably the first type of modeling that you will require. You will require to understand what are the different entities in your system and how do they relate to each other. Okay, this is the first type of analysis you have to do. The second type of analysis you need to do is how exactly does the data changes, right? I mean, it is quite right that whenever you create, let us say, something like int I. Okay, um, what it really means is that I can take any integer value, minus whatever it is, 65,000 something to plus 65,000 something. But in most cases, the actual logical values or legal values for I
may be much smaller, the range may be much smaller than the complete range of integer, right? So in many cases I should, for example, never take a negative value. If it's a loop counter, most of the time the loop counters start from 0, and it when it goes up to, let us say, n or something like that. So having a negative value of I is really surprising. It should not happen. So similarly, for any particular system, whatever is the data that is flowing in the system, whatever is the data that is representing the system, this has certain legal values, certain legal states, and other states are illegal, right? So it should not happen that when in a particular banking system, the sum total of the money that the bank has, provided that the bank does not have any interbank transfers. For a bank, the total amount of money within all accounts should always be the same, right? If I transfer 500 rupees from my account to my friend's account, my account should get debited by 500, and his account should get credited by 500, as thus the total remains the same. If at the end of the day the total changes, throughout the bank without any interbank transfers, then there is a problem. This current state of my bank is illegal. Something went wrong. So whenever you build a system, you will also need to understand, from one state to another, whenever your system goes from one state to another, your application is changing its state, what states are legal and what states are not legal. And then one more aspect of your system is where you have to figure out. So the first part is in some ways what, right? So what consists, what exactly are the constituents of your system. The second part is something about how, right? Like how, as in, uh, uh, how does your system go from state A to state B. And the third part is about when, in some ways, right? So when exactly does the state changes, right? So the answer to when is, whenever the user, for example, in my case of bank transfer, whenever user A requests a transfer of money from his account to another account, then the state changes. Okay, so the third part here is when. So for the first part is what, the second part is how, the third part is when. So these are three. In fact, there are actually many other questions, but when we do modeling, these three are important questions. What does my system consist of, how does my system changes its state, and when exactly do these state transitions happen. So in order to model these three different types of let us say, three different aspects of my system, there are three different types of modeling that I do. So the first type of modeling is the class modeling. So in class modeling, what we do is, it is very similar to what you guys have seen in the previous week. So whatever we saw, in some ways, what did we do? We basically created two classes, and we understood that this is how these two classes are linked to each other, right? And the diagrams that we use to do class modeling are known as class diagrams. Okay. Now, one aspect of class diagram is that they actually capture static relationships within an application. Well, what do I mean by static relationships? These relationships do not change when my system is is currently running, right? So basically, whatever these relationships are, they have to be decided before my system starts running, in some ways, basically, right? So it's not like, for example, there are two classes, class A and B, and in the middle of my application, as the application is currently running, I say, from now onwards, class A does not have this field, or class A has an additional field. Usually these kind of things are not something that are there as part of static relationships. Static relationships are basically relationships between your classes, that how does one class relate to another class, right? Now, these relationships are known as associations. So any relationship between two classes is known as association, and there are two special kind of associations which are represented in a different fashion in a class diagram. The first relationship is the part of relationship. Okay, so when one entity is a part of another entity, so I'll just show you an example. The second example is the type of relationship, when one entity is a specialized version of another entity. So let us see this diagram now. This is I have just tried to I've bloated postal service example a little bit so that I can have some classes to show. Otherwise, there were just two classes. So I've just like included some additional superfluous information in order to make it more bloated, so that you can see some of the aspects of this class diagram. So this is a typical class diagram, and this is how you represent an association. Okay, it says the letter postal request, it is tracked by the an object of type tracking info. This is what I'm trying to say. And here you can say that you can see that I have not included tracking info as part of this class, right? I'm basically writing something like an integer here, and then I have an integer here as part of its field, right? So every tracking info object has an id field. Okay, and I'm linking a letter postal request to an object of tracking info by storing its id here. Is this part clear to everyone? That let us say I have a tracking info object whose id is 51, and this particular tracking info object is created to track a group of products, for example, who are traveling together. This I'm only going to use this integer here. I will store it in this letter postal request form, and whenever I want to track this particular letter, I'll need this integer. With the help of this integer, I can find this object. Let us for example, for now, just assume that there is a way to find a tracking info object by just providing its integer, the id is a unique thing that is that is unique for every object. So in this way, what I can do is I can, given a particular letter postal request object, I can find a corresponding tracking info object and figure out the tracking information for this particular letter. I know it's kind of unnecessary at this point of time, but I have done this just so that I can explain to you what are associations. So here there is an association between this letter postal request class and the tracking info class, and this association is I have shown this as tracked by. So I've just this is just a name of the association I've given it. Similarly, this letter postal request has another association with the letter. So now you remember, uh, in the C++ code, we made letter to be a part of the request, right? But here I have just changed it a little bit. I have said that instead of making letter a part of my letter postal request, I'll say letter objects are independent. Okay, they can be created independently. They are not directly attached to a letter postal request, and each letter object has a unique identifier called id. If I can store that id here, I can somehow manage, I can figure out what letter it is talking about. So this is the overall concept of an association. Now there are two types of associations which I said are kind of special associations. So one of this relationship is known as the superclass derived class relationship. So what is the idea of superclass derived class? We will study more about it when we study inheritance. But just to give you a brief idea, um, when we talk about a postal service request, it could be for a letter, it could be for a parcel, it could be for things as huge as, let us say, coal being sent from point A to point B. So all these are in some ways a request that the postal department gets, right? So I am saying that there is a class called abstract postal request, and there are some fields out there that the request ID, the weight of the product being sent, what is the cost per unit that the postal department is going to charge for it, what is the GST slab in which this particular product lies in, so on and so forth, right? And then I say that letter is just a special case of an item that could be posted, right? We can post parcels, we can post coal, for example. We can also post letters. So a letter is in some ways a specialized form of so a letter postal request is a specialized form of an abstract postal request. So some of the properties that are associated with this, not some, basically all the properties associated with this are also associated with this. So a letter postal request will also have a request ID, it will also have some weight, it will have some cost per unit, some GST slab, so on and so forth. plus there could be some other information. So I probably do not provide tracking information when I'm sending coal from some mine in Jharkhand to somewhere in Gujarat, something like this. I don't provide tracking info for this kind of things, but I have to provide tracking information for letters. As India Post, this is what I'm trying to do. I'm just making very silly examples, but try to understand what I'm trying to say. That there might be certain objects, for example, which cannot be tracked. Okay, and there are certain objects which can be tracked. So I'm just adding the additional aspects of that object here, and everything else is basically copied from here to here. That is the idea, right? So this kind of relationship is known as the superclass or and derived class relationship, and this is very important in object oriented programming. And this arrow is a representation of this relationship, that wherever this arrow is going, this is the super class, and this is the derived class, the class that is deriving some features from this particular class. And similarly, there is a concept of aggregation, where one particular class is essentially a part of a larger class, right? So this tracking info, for example, is going to have a number of objects for transit info, and transit info is nothing more than, which city, what is the received date, and what is the dispatch date. So this is going to be a part, this particular uh, an object of type tracking info is going to have multiple objects of type transit info within it as its parts. So this is the part of relationship. Okay, while this relationship was the type of relationship, this is the part of relationship. We'll discuss more about this when we discuss class diagrams in detail. But overall, the idea is I have some classes and I want to model the relationships between them. So this is the overall purpose for creating class diagrams. Any questions? Okay, so the next thing that we have to do, we have to figure out is, let us say I do have an object, and what exactly do we do in computer science? Essentially, we do computations, right? Uh, what do computations do? You have some values, and with the help of these values, you probably come up with more values, right? This is the overall gist of computation, that you compute something and then you move forward, right? So whenever we say this is a system which has, let us say, these 4 or 5 different types of classes and objects, if I want to tell you what exactly these objects do, another aspect is that, okay, this object is supposed to do these things. Okay, these things, as in the beginning it should behave like this, then it will become this, as computations keep on happening, this is how this particular object's state is going to change. So the state modeling aspect of a system is basically about creating one or more state diagrams. Okay, and what do these state diagrams do? Each one of these state diagrams actually depict how it's in some ways it depicts the life cycle of a particular object, right? That this is how this object starts. Okay, this is the initial state, and from here onwards, if this event happens, this is what happens to the state. If this event happens, this is what happens to the state, so on and so forth. So there is a kind of transition diagram, that how does the states of a particular object transition from one point to another, sorry, one point to another. So this is known as the state modeling using the state diagrams. Now you can understand that if we try to do this for every object in a particular application, certain applications might actually have thousands or even more different classes. So creating a state diagram for all of them may be too tedious, right? So sometimes you might not create these state diagrams for all possible types of objects, but only the ones that are really important for you, for your application, for someone to understand how your application works. And even within the same object, you might not want to show all the possible transitions from state A to state B. You only show the ones that are really important, that are important for, let us say, the developer who is going to build this system, to understand how this object works. Okay, and why do we need this? All those operations that we talk about, a particular class has these operations. In some ways, these operations are coming from your state modeling. Okay, even though in class diagram you probably saw the name of the methods, but usually these things go on in parallel, right? I mean, state modeling and class modeling, so they feed off of each other. So when you do state modeling, you realize, okay, I need another function, another method in this class, so you go and add it in that class diagram. Similarly, when you added it in class diagram and you saw that there is an association between this class and another class, you realize, oh, I need probably another method in this class, so you go and change it in the state model. So essentially you do these modelings. They're not really sequential in nature, they go on in parallel. So with the help of these state modeling, you realize what are the different types of changes that this particular object needs to go through. And in most cases, you'll need to have some methods which can allow this kind of transition, right? So so one of the things is that the nodes of the state diagram are objects states, okay, a particular object states, and these edges are equivalent to some event, like something happened, and because of which the state of this object changed from this to this. That is the overall idea. This is an example of, there are two examples of a state diagram here. So for our letter use case, you knew that when you created the object for letter, it was unsealed. This was by design, and then you have to call some function in order to seal the letter. So initial state of the letter was unsealed, and then it became sealed. Now here I have not shown any initial state, because basically it's too obvious. There's only one state transition that is going to happen for a type of letter, okay, and that is from unsealed to sealed. For objects of type abstract postal request, I basically say that this object has an initial state. And if you remember, in the initial state, we had put the sent date and delivered date to null, or some empty string, something like that, right? And then as soon as I send the post, that send post method was called, the sent date was set to something. Okay. Similarly, whenever the post was delivered to the final receiver, the I think the delivery date or some other date, so there was a field there that was set whenever this particular event happened. So for this particular object, there are two state transitions. It starts from an initial state where both sent date and received date are set to null. Then one event occurs, the sending of the post, which means that now your object's state has changed. Okay, so the sent date is set to some actual date, and then finally when the delivery happens, another state change happens for this request, and that value of the received date also gets updated. So this is the overall idea of a state transition diagram. An event is essentially something that happens in the real world, right? Whenever you are uh, as I said, right? So in this case, sealing the letter, this is done by, let us say, the user. The user seals the letter. It is an event that occurred in the real world. Similarly, the post was sent from the source point, right? And the post was delivered to the receiver. So all these are essentially events. They're kind of alarms you can see in the real world. So whenever some event happens, or there is a kind of a chain reaction, okay, there is an event happened, so so the state changed from I to J, then from J to J dash, from J dash to J double dash, something like this. So basically, it could also be a chain reaction, that the event might not just change the state once, it can actually change the state multiple times based on some logic. Okay, so the idea is that these state diagrams capture this aspect of the system, that what are the real world events that are going to happen, and this is going to change my overall system. Whenever this particular event happens, my system is going to change the state. And as I said, this particular notation is for the start state. We also have another notation for end state. We'll have a look at it when we have a look at state diagrams. Any questions? Okay, so the third type of of modeling that we have to do, as I said, right? So what, how, and this is now when, right? So let us say in the previous case, you this for example, this particular set of state diagrams, all they tell you is that this particular object goes in this state like this, and this particular object goes from this state to this like this, but it doesn't tell you the order here, right? Whether the sealing of the letter happens after the deliver the post event, whether it happens after the send the post event. So how are these two things ordered, with respect to each other? Okay, that is the idea, that this is only going to tell you how the state changes, but when are these things going to happen, what is the ordering between these events? If you want to capture that, this is where we go ahead with the interaction modeling. That now, not only is the aspect, what and how, you also need to understand when. So when do these things happen? So interaction modeling is actually very complex, by the way. Okay, there are multiple ways in which we capture this interaction modeling. There are three types of diagrams that we use: use case diagrams, sequence diagrams, activity diagrams. It is not necessary that we use all these diagrams in a particular application. In fact, in general, we don't. We only Because the overall idea is to somehow communicate it to the developers, to the stakeholders, that this is how the interactions between different objects are going to happen. Okay, as long as you are going to do that, as long as you can do it with some of these diagrams, one or more of these diagrams, you don't need to create all of them. But still, this is an example of an interaction diagram. This is actually a sequence diagram. It is called a sequence diagram. The idea of a sequence diagram is, you actually tell me when do these events actually occur in the real world. Okay, in the real world, so in a sequence diagram, basically whatever is on top happened first, and whatever goes on at the bottom. Okay, so there is an ordering involved here, that this happened first, then this happened, then this happened, then this, then this, then this, and then this, right? Again, the sequence diagram is not really telling you about the time differences. So it doesn't mean that, so for example, I'm not going to measure the distance between this transition and this transition. No, that this is not an information that the sequence diagram can give you. It can only tell you the ordering. So all I can say is, this happens after this, and this happens after this. I cannot tell you what is the actual amount of time after which, right? So it is possible that this transition, the difference between these two transitions is a few milliseconds, and between this and this could be a few hours. Okay, the sequence diagram doesn't capture this. It only tells you the ordering in which things happen. So this is another example of an interaction diagram. There are some more activity diagrams and use case diagrams. We'll have a look at it when we study interaction modeling. So, and this is an example actually of some self loop, right? Because what it is saying is that whenever this event happens, this particular by the way, these are all objects. These verticals are all objects, and this kind of notation says that whenever this event happens, there is a self change. There is a change within the object itself, right? And this is a change where something is going to happen across the object. Okay, something happens from here to here. So we'll study about these loops and these interactions when we study the interaction diagrams. But do you now understand what are these three types of diagrams and why are they used? So the class diagrams, the class modeling, is used to capture the what part of the application, what are the constituents of the application. The state diagrams are used to capture the how part of your system. How does your system change its state from one state to another. And the interaction diagrams are basically going to cover the when part, that when exactly, so what is the ordering in which certain things happen. Okay, so your homework, by the way, is that you have to go and read chapter 1 from this book, right? You have this book. I'm not sure how many of you have even bought it. Probably I should have asked you to do this in the first lecture. But please, buy this book, Object-Oriented Modeling and Design, and your homework is to read the first chapter from the book. Okay, questions? uh, Practice labs. I can give you. I have to write the solutions, but I can write it and send it to you. No issues. Um, so I thought it was not really that big a deal, so I didn't actually write the solutions. Um, but if you guys want, I can write the solutions and send it to you. Okay. Yeah. Any questions? And I do understand that you guys might actually feel this is all theoretical and it's too boring, but this is why we are going to have those projects. Okay, when you do those projects, you'll get a chance to do all this practically. Okay, you'll get a chance to create class diagrams for your problem. You'll get a chance to create state diagrams for your problem, interaction diagrams for your problem, and then it'll probably be much more interesting, right? But for now, just bear with me, try to understand the concepts, try to grasp the concepts. You will get a chance to do the practicals as well. So but now, try to read some theory. I know it's really uh, difficult to make these things interesting. Um, but try to pick up some motivating example of yours, right? I'm trying to use this postal service example. On the internet you will find so many different examples. The common ones are related to employee and company, student and the institute. What else? So these are some very common vehicles. Okay, these are the common examples that people use for teaching object oriented programming and approach. So it's up to you. You can pick up any motivating example. The idea is try to grasp these concepts. What exactly are these different types of modeling? Because this subject is called object oriented modeling. It is not object oriented programming. Okay, so I have to teach you some modeling. In fact, I had made it very clear with the authorities that what exactly is expected. Am I just expected to teach you programming, or am I also expected to teach you modeling? And it was made clear to me that I also have to teach you modeling. So please, right? I mean, bear with me. You have to you will get to do these designing things in software engineering again. But for now, please try to understand the basics. Any questions? Okay, I think it is a holiday. Yeah, we will have to see what to do. I don't think we have a lab now. I think on Wednesdays. What is there in the new timetable? I think the lab has been shifted to Tuesday and Friday, if I'm not wrong. Let me check it. Uh, Timetable.
Sir, it's Wednesday and Friday.
Okay, okay. Sorry. So just a minute. This is for okay. For CSAI, it
For
is wait. IT plus CS, and this is for CSAI. For CSAI, it is Friday now, guys. Your labs are on Friday now. Check out your new timetable. Okay, and for IT plus, it is on Tuesday. We now have what we will miss on Wednesday are lectures. Okay, we will miss one lecture each for both batches. So for that, I'll need to take some extra lecture maybe. But we are not going to miss on the labs. Okay, the labs are on Tuesdays and Fridays. So you will have your practice labs this week. Your mentors will sit with you for 2 hours, and I will try to give you a problem to solve. Okay. Any other questions? Okay, so do this. It could have been difficult for you to follow the aspects of this lecture, because as I said, it's basically theory as of now for you. We have not done any practical on this. This is why, please go and read the chapter one of that book. If you read chapter one, it'll give you a lot of a good perspective of what things are. Okay, and In fact, if you can understand chapter 1, you should also go ahead and read chapter 2. Chapter 2 is very small. I think only 2 or 3, what is it like, 3 pages or so. So if possible, after chapter 1, please also read chapter 2. It'll make you understand whatever we covered in this lecture. Okay, if you cannot understand the lecture today, please read those 18 to 20 pages of the book, and you should understand whatever we did today. Okay, so any queries, or shall we break? None. Okay, guys, then
Hello,
thank you.
sir. I have
Bye.
a doubt.
Y- Do you have a question?
Yes, sir.
Yeah, go ahead.
Sir, can you explain again the part of and type of relationship with example,
Type of what?
postal example? Part of relationship and type of relationship.
Okay, part of and type of. Okay, okay, just a minute. So, let me tell you this. Whenever we talk about a particular vehicle, right? What are the attributes of a vehicle? A vehicle certainly has some wheels, right? This is the first thing that you should know, that if it is a vehicle, there will be wheels. Now, the actual number of wheels will be different for different types of vehicles. You will have, in a two-wheeler you will have two wheels, right? In a three-wheeler you will have three wheels. In a four-wheeler you will have four wheels. Similarly, there could be other wheelers as well. But every vehicle will have some number of wheels, right? That is quite sure. So, one way to say that, let us say I want to create two classes, one to cater to two wheelers, bikes and scooters and stuff, and another one to cater to four wheelers, the different types of cars. Now I can create two different classes here, one for bikes and one for classes. Or what I can say is, I can start with, let us say, a vehicle class. I can say, okay, a vehicle must have number of wheels. The number of wheels will change for a car, and it will change for a for a for a scooter. Similarly, every vehicle will have a fuel type. It could be petrol, it could be diesel, it could be CNG, it could be anything else, right? But every vehicle will have some fuel type. So what I can say is that, let us say, in a typical world, when I need more than one um, classes which are in some ways related to each other, many a times I can actually abstract out certain common properties between these classes and put it in a different class, and then I can say that these classes that I'm trying to build are in some ways a special case of this abstracted class. Okay? So I can say that vehicle is an abstracted class which has properties like number of vehicle and fuel type. And then a scooter is a special case of a vehicle where the number of vehicles, when number of wheels are equal to 2, and let us say the fuel type is equal to petrol. Similarly, Maruti Alto 800 is a special case of a vehicle which has four wheels, and whose fuel type is, let us say, petrol or CNG or whatever it is. So this is the concept of a generalization, that many a times in object oriented programming I generalize one class in such a way that I can derive multiple classes out of it. It is helpful for me to model it like this. So this is known as the type of relationship, and we will study about it when we have a look at the concept of inheritance. So here I am saying that, the request to post a letter. Okay, I am saying that the postal department might actually send other items as well. Okay, not just letters, parcels, and even complex things. It may be able to parcel it, right? Some of these things might not even have tracking ID. So I say that, let us try to abstract some of the properties of a letter postal request to a different class. Now, there could be another class here which says parcel postal request, and that too will basically be a special case of abstract postal request. And the properties of abstract postal request are basically copied to the letter postal request as well as that parcel postal request. This is the idea, right? So the overall thing is uh, generalization. In fact, this is what I so these properties are copied here as well as a new class, let us say I create here, and these properties will be copied there as well. So this type of relationship means that there are some properties which are part of a class. These are automatically copied to the derived class, plus the derived class can add some more properties to it. That is the idea. So this is the type of relationship, that letter postal request is a type of abstract postal request. Similarly, here I also had another type of thing. Um, a letter is a type of postable item. A postable item has the sender, receiver stuff, and like this, right? Whereas a letter has a property whether it is sealed or not, right? So this is an additional property. All these properties are being copied to letter. Plus, letter also has another property called being sealed or not. So this is the type of relationship. Letter is a type of postable item. Scooter is a type of vehicle. Maruti Alto 800 is a type of vehicle. Similarly, the part of relationship is where a particular class is going to have a field which is essentially a complex field. Complex as in it is not a simple, uh, it's not a primitive data type. It's basically another object, right? There is nesting involved here. So here you can see that in this particular case, the tracking info object, it is going to keep a number of transit info objects. This is equivalent to, if you have ever seen the India Post tracking page, they show you rows, right? Your For example, your package started from Lucknow on 12th April. It left at this point of time. Then the next entry is it reached Kanpur on 13th April this time. Then it left Kanpur from 13th April. It reached, let us say, Delhi on 15th April, so on and so forth. So all of these rows, they probably correspond to one transit info object, and the tracking info object is keeping a list of these. That is the idea. So so there is a part of relationship, that a transit info object is a part of a tracking info object. That is the idea. Is it clearer now? We will study
Yes,
about it
yes.
in detail. Yeah, we'll study about it in detail when we study class modeling. But that is just to give you an idea that these are the kind of relationships we are trying to capture. Any other queries, guys? Okay, please go and read chapter 1, and if possible, there are like only 3 more pages, chapter 2 from the book. And before that, please buy the book if you have not yet bought, or arrange it from somewhere. I don't know how, but arrange it from somewhere. It's a very important book. If you study it, it is going to be very important for you. So please do it. Okay, guys. Thank you. Bye.